We are going to look at number patterns with a constant ratio. In the previous lesson, we looked at number patterns with a constant difference, and we called those number patterns linear patterns or arithmetic patterns. Number patterns that have a constant ratio are also referred to as geometric. So if you want, these are called geometric number patterns. Let us look at an example. We are given three terms of this sequence. The first term is 2, second term is 8, and the third term is 32. Now this time, if you try to subtract 2 from 8, the answer that you get will not be the same as 32 minus 8. That tells you straight away that this particular number sequence is not arithmetic or linear. But if you look at this one carefully, you can multiply 2 by 4, that will give you 8. And you can multiply 8 by 4, that will give you 32. This means this particular number pattern is formed by multiplying each term by 4. And so this is called a geometric number pattern. The 4 is referred to there as the constant ratio. Our constant ratio of 4 can be found by dividing, say, T3 by T2. If you do that, that will give you 32 divided by 8, which is actually equal to 4. Or you can take T2 and divide it by T1. You will get the same answer. So to answer this question here, the constant ratio is equal to 4 because that is what we get if we do the division there. The second question says, write down the next two terms. So we are extending the number pattern by 2 more terms. The first 3 terms are 2, 8, 32. And we know that we should keep multiplying by 4. So it's easy to write the next 2 terms. Just multiply by 4 and you'll get your answers. So the next 2 terms, the first one should be 32 multiplied by 4, which should give us 128. And the next one should be 128 multiplied by 4, and that should give us 512. So these are the next 2 terms for that particular sequence. Then question 3 says, determine the general term Tn. I'd like us to use a method where we try and relate the constant ratio to the position of the term. So we have the position of the term and then the term itself. In position 1, there is a 2. In position 2, we have 8. And in position 3, we have 32. Now, we want to find what is in position n. And we know that in position n, we have Tn. So we need to find Tn. If you look at the first term, T1, now T1 is equal to 2. And 2 can be written as 2 multiplied by something. And I need that something to come from the constant ratio. The constant ratio, remember, in this case, is equal to 4. So the constant ratio is 4. And I need 2 to be my answer. So 2 should be multiplied by something in terms of the constant ratio. It can't be 2 multiplied by 4 because 2 multiplied by 4 will give me 8. I need to get an answer of 2. That only means I can multiply 2 by 1. But 1 is what we write as 4 to the power of 0. Remember, I want to make use of the constant ratio. So the first term can be written as 2 multiplied by 4 to the power of 0. I need us to take note straight away. The first term means this is a term in position 1. So if a term is in position 1, then it means the ratio will be using the exponent of 0. Hope you can see that. In position 1, or for position 1, the exponent is 0. T2. We all see that T2 there is equal to 8. All right. But because the first one, I wrote the first one there as 2 multiplied by something, I'll start again with 2. So I need to write 8 as 2 times something. So I need something in here. But that in there should make use of the constant ratio, which is 4. We know that the constant ratio is 4, so the constant ratio will always be a base. So all I'm looking for here is the exponent. So what is the exponent so that I get an answer of 8? You will notice the exponent will be equal to 1. Once again, look at the relationship between the position. The position of the 8 is 2. So 8 is in position 2 and the exponent is 1. If the position is 1, then the exponent is 0. If the position is 2, then the exponent is 1. You can expect for position 3, the exponent to be equal to 2. So let's look at that one together. So T3 is equal to 32. But I want to write 32 in the same format as the other numbers. So I'll start 2 multiplied by something. I need that to give me 32. And I need the base in there to be a 4. So what is the exponent? So that I can get a 32. Do you see that? That will be 4 to the power of 2, because 4 squared will give you 16. And 16 multiplied by 2 will give you 32. If T1 is equal to 2 multiplied by 4 to the power of 0, and T2 is equal to 2 multiplied by 4 to the power of 1, and T3 is equal to 2 multiplied by 4 to the power of 2, what is Tn? In general, it means Tn should be equal to 2 because all these are starting with a 2. Therefore, Tn must also start with a 2 multiplied by base 4. You see, all these are using base 4, and so Tn must also use base 4, and that will be to the exponent of n minus 1. I'm getting n minus 1 from here. The exponent for T1 is 0 because the position is 1. If you move on, position 2 gives us an exponent of 1, that is 1 less than 2. Position 3 gives us an exponent of 2, that is 1 less than 3. Therefore, position n must also give us 1 less than n, and this becomes the formula. The first term, T1, is equal to 2 in this example. For number patterns, we also write the first term as A, so T1 is equal to A. So from now onwards, we can use A instead of T1. And the constant ratio is called R. This is your constant ratio. Remember, in our example, the constant ratio is equal to 4, and our A is equal to 2. So if you go back to that formula there, you can actually tell that the general term Tn is always the first term, which is A, multiplied by the constant ratio, which is R, to the power of 1 less than n, which is R to the power of n minus 1. You can use this formula. So in future, if you get a number pattern, just identify what A is and work out your constant ratio, and you can just substitute into this formula here. So if you substitute this one here, that is why you will then end up with Tn is equal to 2 multiplied by 4 to the power of n minus 1. If you know Tn, we know Tn is equal to 2 multiplied by 4 to the power of n minus 1. You can find any other term, like T9. T9 means where there is n, we now put 9. So this will be 9 minus 1. And so T9 will be 2 multiplied by 4 to the power of 8. You can multiply using your calculator. 2 multiplied by 4 to the power of 8 will give us 131,072. So that is the 9th term of this number pattern. And finally, again, remember that Tn is equal to 2 multiplied by 4 to the power of n minus 1. Which term of the number pattern is 2048? Now we are given Tn. So where there is Tn, we put 2048. So this means 2048 is equal to 2 multiplied by 4 to the power of n minus 1. Clearly, the first thing we need to do is to get rid of that 2 there. We are trying to find n, so we need to get rid of the 2 from the other side. And this will give us 1024 is equal to 4 to the power of n minus 1. The only method that we've learned so far in grade 9 for solving exponential equations is to make sure that we prime factorize our bases and use the same base. So if you prime factorize 1024, you will get 2 to the power of 10. So this is actually 2 to the power of 10. 4 means 2 to the power of 2. Then you need to multiply that by n minus 1. And this will give us 10 on the left-hand side is equal to 2n minus 2 on the right-hand side. If you solve that equation, you will get n is equal to 6. Right, so that means 2048 is the 6th term.